Hi everyone, so today you are going to be watching a short video that starts talking about how we find the area of what we call composite shapes. And today we're going to focus on trapezoids and hexagons and octagons. When we talk about composite shapes, also called compound figures sometimes, really the definition of a composite shape is just any shape that is made up of or composed of other shapes that we know. So for example, we could break a composite shape down into rectangles or triangles or even parallelograms, but those are more common shapes that we have area formulas for and we're able to use to solve them. So like I said, today we're going to be focusing on those trapezoids and hexagons and octagons, and then on Monday we'll look at some other composite shapes that are more funky looking, like a house looking shape or an arrow, and breaking those down. So when we're looking at these trapezoids here, we want to find ways that we can split these trapezoids into shapes that we know. And looking at the trapezoid, we should be able to split this into triangles and rectangles. So if I split it where this height was marked with the dashed line and then split it here again, you can see that I've split that into a rectangle and into two triangles. Now, all we have to do is find the area of those three pieces. So we're going to start with the easier of the three, which is the rectangle. And if we look at the rectangle, we're doing length times width, which is going to be our 5 up top here and our 4 here. So the way I'm going to show that is I'm going to put A for area, and then I'm drawing a little rectangle to show that here's my work and my answer for that rectangle. So 5 times 4, length times width, is an area of 20. Now my triangles, and I have this shape actually up hanging on the board made out of blue paper, is 2 triangles, and we know that the entire base here is 12 feet. What we do know is that this section that is made up of the rectangle is 5 feet, but we don't know how long these 2 triangle bases are. So we could say, well, the whole thing is 12. If we take 5 away from 12, we're going to have 7 feet left over that are split between those 2 triangles. We don't know though, is it 6 feet here and 1 foot here? Is it 2 and 5? Is it 3 and 4? We could make some assumptions based on what it looks like, but we're not sure. We're not going to know for sure. So what we can actually do is we can pretend that we're going to chop both of these triangles off the end. And if I drag those 2 triangles off the end and place them next to each other side by side, I can just form one giant triangle rather than solving them as 2 individual triangles. So if I put them together and make one giant triangle, it's going to have a base of 7, which again was what was left over when I took the 12 and took out the 5 that was being used for the rectangle. So we have 7 left and that height of 4 feet. So now if I find the area of that triangle, base times height divided by 2, since it's a triangle, 7 times 4 is 28. 28 divided by 2 is 14. So I've got an area of 20 for the rectangle. I've got an area of 14 for those 2 triangles put together. My last step is just going to be to add those 2 areas together to get a total area of 34 square feet. I changed to this green trapezoid and got rid of some fractional length so that we've just got whole numbers to work with. Same thing, it's another trapezoid. Difference is only one side is slanted. So the way I can break this in is I've got a rectangle and just one triangle on the side. So same thing when I go to find my area here. I'm going to start with my rectangle. If I look at my rectangle, I've got an area of 6 by 3 are my 2 dimensions. So my area of my rectangle is going to be 6 times 3, which is 18. And then I've also got my triangle on the side. No need to break that off and combine it with something else because there's only one triangle here, but I do need to find my missing dimensions. So if I look for those missing dimensions, here's my right angle that I kind of drew in when I cut that off. The height is going to be 3, and I know that because the side length over here of the rectangle was 3, which tells me the opposite side is 3. And then to get the base of this triangle where that right angle is, this whole distance was 8 yards. I used 6 of those yards for the rectangle, so 6 of it is being used, which leaves me with 2 yards for the base of the triangle. So when I go to find my area of my triangle, I'm going to do base times height divided by 2. 3 times 2 divided by 2 gives me an area of 3. Same thing to get my area, my total area. I'm going to take 18 and add it to 3 to get 21 square yards. I can look at hexagons and octagons the same way as a composite shape. My goal is to break them down into shapes that I do know. So oftentimes people think, well, oh, I could break that into 2 trapezoids, which I could, but I don't have a formula for a trapezoid. I considered it a composite shape, so I'd have to break that down farther. So the easiest way to break any hexagon or octagons down is to connect all of our opposite corners, and it's going to form all of these little triangles on the inside, which makes it a lot easier to solve because all of those triangles are going to be the same. So if I look at this and I'm finding the area of one of those triangles, up top here, I have a base of 4 inches and I have this height of 3.46 inches. So to get the area, I'm going to say it's 4 times 3.46 divided by 2. Go ahead and plug that into your calculator. And that should give you an area of 6.92. That 6.92 represents one triangle of this hexagon because it was base times height divided by 2. All I need to do now is take that 6.92 and I'm going to multiply it by 6 because I have 6 of those triangles in the hexagon that are the same area. That's going to give me an area of 41.52 inches squared. Down at the bottom, I have another shape that looks similar, but if I compare this shape at the bottom to the one up top, this has 8 sides compared to the 6 up top. So we're going from a hexagon to an octagon here, but I can approach these the same way. If I connect my opposite corners here, I'm going to end up with a bunch of little triangles. So if I look at those triangles, right here is one that's labeled. So my base right here at my right angle is that same outside length of 12.6, and my height here is 15.2. So I'm going to start, same thing with my area of a triangle formula from yesterday. Base 12.6 times height 15.2 divided by 2. Go ahead, same thing, plug that into your calculator to see if you can get my same answer. That gives me an area of 95.76. That 95.76 is base times height divided by 2. It's one triangle section out of that octagon. On this problem, since it's an octagon, we have 8 equal triangles if I count them. So I'm going to take that area and I'm going to multiply it by 8 to get a total area. And that total area should be 766 8/100 inches squared. So in your notebook, we're going to go ahead and label the trapezoid real quick, break that down, and put it in our notes, and then you're going to spend the rest of class time working on some practice with these shapes. So if you look at your trapezoid, we ended up splitting a trapezoid like this into 2 triangles and a rectangle, so go ahead and draw those splits in. Make sure you're labeling those right angles. And then underneath on this one, instead of putting an area formula, because there isn't a specific formula, we're going to, and not do an example, we're just going to write that we need to break this into a rectangle and triangles. So again, your goal for all of your trapezoids, hexagons, and octagons that you're going to be practicing today is to break them into familiar shapes. So shapes that we have formulas for. It's going to be your rectangles, your triangles, and your squares. Find any missing side lengths that you need, and then find those individual areas and combine them. You're going to work on a practice worksheet that's got 5 of these shapes. Take your time on it. There's multiple steps for each of these. And when you're finished at the end of class, you're going to check to see how well you did.